Students, now we'll talk about another error detection technique, and the name is checksum. Students, checksum is once again an error detection technique which can be applied to a message of any length. Students, checksum is normally dealt with at the network and the transport layer, but because we are talking about the error detection techniques, I will introduce you briefly to checksum as well. Students, as you can see on the slide, we have got a sender end and we have got a receiver end as usual. At the source, the first step is that this message that we have got is divided into M bits. So we create multiple units, each of M bits. Students, the generator then creates a checksum of M bits. So the same number of bits in the checksum as the bits that we have got in each of the units that we have divided our message into. Students, we append this after the overall message that we are sending. So message plus checksum. We don't necessarily, in real life, we don't necessarily need to append it at the end. We can actually insert it anywhere in the message. But what's happening is we are sending the message plus this checksum, this combination, we are sending it to the receiving end. Students, at the destination, the checker creates another M-bit checksum. Now, students, if the new checksum that is created by having these M-bit data and this checksum, if the result that comes out, the M-bit result that comes out, the message, if it is all zeros, as you can see, if this new checksum, if it is all zeros, the message is accepted. If this is not equal to zeros, the message is discarded. Students, the actual concept behind this checksum is very simple, and we'll show it to you using a small example. Students, as you can see, the example is that we have got a message and it's a list of 5 4-bit numbers. 7, 11, 12, 0, and 6. And we want to send these numbers to the destination. So students, in addition to sending these numbers, we send the sum of the numbers as well. Now, in this particular case, as you can see, we have got this 6 out here. Students, originally, the set of numbers that we need to send, the checksum comes out to be, for example, if you've got 5 numbers, then 7 plus 11 plus 12 plus 0. This is plus 6. This is equal to 36. So students, what we'll need to send is 7, 11, 12, 0, 6, and 36. This is going to be our message appended with the checksum, where your 36 is nothing but the sum of the original numbers. Students, the receiver adds these 5 numbers and compares the results with the sum. If the two are the same, the receiver assumes that there is no error and accepts this data. If they are not the same, it discards the sum. Students, in this particular case, there is a bit of a drawback. Students, as you can see, each of these numbers here, 7, 11, 12, 0, and 6, they can be written as a 4-bit word. Each of these numbers is lesser than 15, so they can be written as a 4-bit word. Students, in this case, your checksum cannot be written, which is 36, cannot be written as a 4-bit word. So, students, let's go to the next slide and try to find out what the solution is for that. So, students, we have got a decimal number 36, and in the binary, this cannot be expressed as 4 bits. You need more than 4 bits in this case. So, students, what we do is, to change this to a 4-bit number, we add the extra leftmost bits, which are 1 and 0, in the binary to the 4 bits on the right. and this comes out to be 0110 using modular arithmetics once again, and this is equal to 6 in decimal. So students, instead of sending the message plus checksum combination of 7, 11, 12, 0, 6 and 36, because we are using 4 bits, what we actually send is 7, 11, 12, 0, 6 and 6. Now our checksum is also in 4 bits because we needed to send it and we have changed it to a 4-bit number. So students, the receiver will add the first 5 numbers in 1's complement. What we have essentially done out here is that we have used 1's complement arithmetic. So the receiver will again add the 5 numbers in 1's complement arithmetic, and if the result is 6, then the numbers are accepted or the code word is accepted, otherwise they are rejected.